Hey everyone, let's start looking now at force diagrams. And we're going to start off by looking at the forces acting on this block, which is on top of the 2x4. All right, so I'm just going to look at the forces acting on the block. Are there forces acting on the 2x4? Absolutely. We're not going to concern ourselves with those at this point in time. I'm just interested in the forces acting on the block. And we're going to start off by doing it when the 2x4 and the block are level with the ground. All right, so here's my block, or the representation for my block, and I want to examine the forces that are acting on it. But keep in mind, as I'm examining the block on the 2x4, the only thing touching the block is the 2x4. I'm not touching the block, right? But the 2x4 is in contact with the block. So remember that there were two kinds of forces, long range and short range. Long range forces can act at a distance, but all the short range forces require some sort of contact. And so the only thing that can exert a short range force on the block is the 2x4. All right, so there was one long range force that we're going to be using. There was electromagnetic, we're not going to be using that one, but there was gravity. So there's a gravitational force acting on this, and that's going to pull down. Gravity always pulls down when you're near the surface of the earth. So I'm going to draw that force down, and I'm going to label it mg. Okay, mass times gravity. You could call it W for weight. It's the same thing. I'm just going to be consistent. I'm just going to use mg whenever I do gravitational forces in my force diagrams. The other thing that's new that you're not going to see in your textbook is I'm going to do what I call define the forces. What kind of a force is it and what's causing it? So in this case, it's a gravitational force. And so I'm just going to say gravitational force. And that's due to the earth. Right? It's the gravitational attraction between the earth and the block that's at play here. And it's acting on the block. And that's what I call a definition for the force. I tell you what kind of a force it is. There's only four kinds: gravity, normal force, tension, and frictional force. That's it. There's only those four. It's caused by the earth. It's long range, so it can act at a distance. And it's acting on the block. Whenever I do a force diagram for an object, like in this case the block, all of my forces will be acting on the block. Are there forces acting on the 2x4? Yes, but I'm not doing a force diagram for the 2x4. I'm only doing it for the block. All right, so that's that force. Then there's another force pointing up, and I'm going to label that F sub n, and I call it F sub n because it's a normal force. Right, so this is a normal force. And a normal force is short range, so it has to have physical contact. The only thing in physical contact with the block was the 2x4. So it's got to be caused by or due to the 2x4. And it's acting on the block. So those are the only forces acting on the block. Right? There's no frictional force in this situation. There could be, but there isn't in this situation. We'll get friction in the next one. And that's going to be the force diagram for the block on the 2x4. Now, let's tilt it at an angle. Right? I'm actually going to tilt it this way. All right? I don't want to tilt it too much there. So if I tilt it at an angle, let's do the force diagram again. All right, so if we do the force diagram again, there's going to be a gravitational force, and that's pointing down. Right, it's pointing down. I don't want to rewrite this. Gravitational force due to the earth acting on the block. Same definition. Same definition. There's also a normal force, but remember, by definition, the normal force is perpendicular to the surface. So if I'm talking about the block on the 2x4, the 2x4 is the surface, or the bottom of the block is the surface, and that's at an angle. So I want to be perpendicular to that. So perpendicular to that surface is in this direction. So that's the normal force. Same definition. Normal force due to the 2x4 acting on the block. Exact same definition. Now in this case, there's another force, and that other force is friction, because it wants to slide down the block, but down the 2x4, but it doesn't. The block wants to slide down the 2x4, but it doesn't. So there must be a frictional force opposing the sliding, not the motion. In this case, it is the motion, but not necessarily. It opposes the sliding, so it's down. Sliding is down the incline, so the frictional force must be up the incline. So I'll call that little f. Little f is the symbol I use for friction. Right? And that's going to be friction. And that's due to the 2x4. The 2x4 is exerting the frictional force on the block. So I say due to the 2x4. I don't want to keep writing due to, so I'm going to abbreviate dt due to the 2x4. And then acting on, I don't want to keep writing acting on, so I'm just going to write AO, acting on the block. And there's the force diagram for the block on the incline. Okay? Now, one thing I'll point out before we get too crazy here is when I do this kind of a problem, I need coordinate axes. Because I'm going to write equations. I'll write the equations in a future video, but we're going to have to write equations. So when I do that, I want to make the axes convenient. So for this one, I would make the x-axis to the right and the y-axis up, because that's convenient. For this one, however, interestingly enough, it's more convenient for the x-axis to be along the incline of the 2x4. And that's going to be really more critical when we get into dynamics, but we're going to go ahead and do it here. And then the other axis, the y-axis, always perpendicular, is going to be perpendicular to the incline. And we're going to see this is going to make my force equations a little easier to do. And we'll get to those later on. All right, so there's an introduction to force diagrams. If you have any questions, please leave them in the comments below. Thank you.